Hello and welcome to this video. In this video we will learn about theory of harmonic progressions and solve 10 problems. There will be only 20 problems which I will solve in harmonic progression, and there is a reason why there are so few problems with harmonic progression. So let's get started with theory. So what it says is unequal numbers A1, A2, A3 are said to be in HP if 1 by A1, 1 by A2, 1 by A3 and so on are in AP. So you observe that in an HP there cannot be any term as 0, because that will make the reciprocal in arithmetic progression infinite, which will actually mean that all the terms are infinite. The reason is that if any term is non-infinite and common difference is also less than infinity, that is a number, then adding two finite numbers does not give you infinity. So alternatively, we can write that nth term of an HP is equal to 1 by corresponding term in corresponding AP. Now, if A is the first term and B is the nth term, then common difference D is given as 1 by B minus 1 by A by n minus 1. So this is the common difference of corresponding arithmetic progression. There are no special properties of an HP. So whenever we will need to solve the problems of HP, we will treat its reciprocals as an AP. So let's get started with the problems. Problem number 1 says find the 100th term of the sequence 1, 1 by 3, 1 by 5, 1 by 7 and so on. So clearly we see that corresponding arithmetic progression is 1, 3, 5 and 7 and so on. So first term is 1 and common difference is 2. So we substitute this to get 100th term as 199. So the corresponding 100th term in harmonic progression would be 1 by 199. Problem number 2 says that if pth term of an HP is QR and qth term is RP, prove that rth term is PQ. So we again use the corresponding AP. The pth and qth term would be 1 by QR and 1 by, sorry, there is a mistake here, 1 by QR and 1 by RP. So this should be RP. So for AP, nth term is given as A plus n minus 1 into D. So we write pth term 1 by QR is equal to A plus P minus 1 into D. Qth term as 1 by PR is equal to Q plus A plus Q minus 1 into D. Now we subtract these, we get Q minus P by PQR is equal to Q minus P into D. So Q minus P will get cancelled and common difference would be 1 by PQR. Now we substitute this value of D in over here. So we get 1 by QR is equal to A plus P minus 1 into D. We substitute D is equal to 1 by PQR, which gives us A is equal to 1 by PQR. Now we know A and D. So we can find out the rth term, and rth term would be 1 by PQ. So the corresponding term in arithmetic progression would be PQ. Problem number 3 says that if the pth, qth and rth terms of an HP be respectively A, B and C, then prove that Q minus R into BC plus R minus P into CA plus P minus Q into AB is equal to 0. So the corresponding terms in AP would be 1 by A, 1 by B, 1 by C. So we let X as the first term and D as common difference. So 1 by A is equal to X plus P minus 1 into D. Now we multiply this with ABC. So it becomes BC is equal to ABC into X plus P minus 1 into D. This D should be inside the bracket. Okay. So now we multiply this whole thing with Q minus R. So we get Q minus R into BC is equal to Q minus R ABC into X plus P minus 1 into D. Similarly, for qth term, we will have R minus P into CA is equal to R minus P into ABC. multiplied with x plus q minus 1 into d. And for rth term, we will have p minus q into ab is equal to p minus q into abc multiplied with x plus r minus 1 into d. Now, if we add all three, then we will have our required result. So I have left that to you. Problem number 4 says that if A, B, C are in HP, prove that A minus B by B minus C is equal to A by C. So we are given that A, B, C are in HP, so the corresponding AP will have 1 by A, 1 by B, 1 by C. Therefore, we can write twice the middle term is equal to first term plus third term. So 2 by B is equal to 1 by A plus 1 by C. So B comes out as 2AC by C plus A. Now we substitute this value of B in A minus B by B minus C. So we substitute here and we get this as A minus 2CA by C plus A divided by 2CA divided by C plus A minus C. So upon solving this, you get A square minus AC by AC minus C square, and then you take out A common on numerator and also C common on denominator. So that gives you A by C as the final result. Problem number 5 says that if A, B, C, D are in HP, then prove that AB plus BC plus CD is equal to 3AD. So A, B, C, D are in HP, therefore 1 by A, 1 by B, 1 by C, and 1 by D will be in AP. This should be D, not C. So we let X to be the common difference. Then what we have is 1 by B minus 1 by A is equal to X, which gives us AB is equal to 1 by X into A minus B. Similarly, BC will give us 1 by X into B minus C, and CD will give us 1 by X into C minus D. Now we add all this, so we get left hand side AB plus BC plus CD is equal to 1 by X into A minus D. Now we substitute the value of X in terms of A and D. So AD is fourth term, so it would be 1 by D minus 1 by A divided by 4 minus 1. So that gives us 3AD. Problem number 6 is that if x1, x2, x3 up to xn are in HP, prove that x1, x2 plus x2, x3 plus x3, x4 up to xn minus 1 xn is equal to n minus 1 into x1 into xn. So this problem is similar to problem number 5. So like problem 5, we have let d to be the common difference, and then we write 1 by x2 minus 1 by x1 is equal to 2, giving us x1 x2 is equal to 1 by d into x1 minus x2. Similarly, we will have 1 by x3 minus 1 by x2, d is equal to x2 x3 is equal to 1 by d into x2 minus x3, and so on. We write for the nth term. Oh, this is wrong. It should be 1 by xn minus 1 by xn minus 1. This is not plus 1. Is equal to d. It will give us xn minus 1 into xn is equal to 1 by d into xn minus 1 minus xn. So if we add all this, 1 by x2 will get cancelled here. Similarly, 1 by x3 will get cancelled. Similarly, 1 minus xn will get cancelled. What we will have is 1 by xn minus 1 by x1. So on the right hand side, sorry, we don't add over here. We are adding these things. So finally, if we add this, we will have x1, x2 plus x2, x3 plus up to xn minus 1 into xn. And over here, x2 will get cancelled, x3 will get cancelled, and xn minus 1 here will get cancelled. So right hand side would be 1 by d is equal into x1 minus xn. Now this is nothing but 1 by xn minus 1 by x1 is equal to n minus 1 into d. So substituting these value, we can obtain the desired result. We substitute the value of d from this equation over here, just like 5. Problem number 7 says that if A, B, C are in HP, show that A by B plus C, comma B by C plus A, comma C by A plus B are in HP. So A, B, C are in HP, which means 1 by A, 1 by B, 1 by C are in AP. So we multiply everything with A plus B plus C. So we get this as a result. Then we divide, so A will get cancelled, 1 plus B plus C by A, comma 1 plus C plus A by B. Here B will get cancelled, and here C will get cancelled, 1 plus A plus B by C are in HP. Now from these we subtract 1. So we get B plus C by A, comma C plus A by B, comma A plus B by C are in HP. Now we take reciprocals and we get the final value. Problem number 8 says that if A square, B square, C square are in AP, show that B plus C into C plus A into A plus B are in HP. So we are given that A square, B square, C square are in AP. So we can write this as B square minus A square is equal to C square minus B square. Now what we do is we divide both sides by A plus B into B plus C into C plus A. When we do that, B plus A will get cancelled on the left hand side. We will be left with B minus A by C plus A into B plus C. And over here, C plus B will get cancelled. So we will be left with C minus B into A plus B into C plus A. We can rewrite this as B plus C minus A by C plus A into B plus C. We have added C and we have subtracted C. On the right hand side, we add A, we subtract A. Now over here, this will become 1 by C plus A minus 1 by B plus C is equal to 1 by A plus B minus 1 by C plus A. Now we see that from this, we can write that 1 by B plus C, comma 1 by C plus A, comma 1 by A plus B are in HP. Therefore, in AP, not HP. This would be in AP. And therefore, reciprocals would be in HP. Find the sequence whose nth term is 1 by 3 n minus 1. 1 by 3 n minus 2 is this sequence and HP. There is a spelling mistake in this. So T1 is 1, T2 is 1 by 4, T3 is 1 by 7. So nth term of the corresponding AP would be 3n minus 2. And n minus 1th term of the corresponding AP would be 3n minus 5. So common difference would be, this should be tn minus 1, which would be 3, which is a constant. And thus we can say that corresponding reciprocals will form an HP. Problem number 10 says that if mth term of an HP be n and nth term be m, prove that m plus nth term is equal to mn by m plus 1 and mnth term is equal to 1. So we have an AP where mth term is 1 by n and nth term is 1 by m. We let A to be the first term and D to be the common difference. Therefore, Tm is equal to A plus n minus 1 into D is equal to 1 by m. And nth term is A plus n minus 1 into D is equal to 1 plus 1 by m. We subtract, we get m minus 1 into D is equal to m minus n m minus n by mn. So we get D as 1 by mn because m minus n will get cancelled. Now we substitute this value of D in Tm over here. So we get A as 1 by n minus m minus 1 divided by mn, which gives us 1 by mn. Now we have A and we have D. So our m plus nth term would be, on solving the equation, m plus n by mn. And Tmn would be 1, as shown here how it has been evaluated. With this, we come to the end of this slide. I hope you have enjoyed this and found it useful. If you have found this video useful, then please subscribe to the channel and like the video because it motivates me to make more videos. Thanks a lot for watching the video. Enjoy.